Example 9.2. Let's assume that Delta Airline wants to invest $375 million in a new hub. The setup cost includes purchasing gate access, aircraft maintenance facility, adding retail points, and other activities. The company expects its retail cash flow to be $25.51 million in the first year and grow at the rate of 15.02%. So G here is 15.02% for 15 years, and then constant thereafter. No, I think we've grown this by 15% all through. Compute the 20-year cash flow analysis as used by the finance manager. MARR is set at 15%, and for the sake of simplicity, assume that the inflation is constant at 2%. So let's get going. Minus 375, and then 25.51. Let's put the growth rate here at 15.02%, right? 15.02. So equals previous value times parenthesis 1 plus $G $1. So it's going to grow. So this is going to grow all the way, and that's why we said it's not going to be constant. So it's going to go all the way till the 20th year. Now, that's the first one. The second one, so these are the nominal cash flows. Now we're going to do real cash flows, that is inflation adjusted. And the method here is CF real T is CFT divided by 1 plus pi to the power T. So this is CFT. So this is CF real first method, this is CF real second method, this is CF real third method. So we find out the real cash flows, and so we just say this is nominal cash flow. So equals this divided by 1.02, which is the inflation rate, to the power of 1. That is the real cash flow for that particular period. And so all the real cash flows can be found out like this. So just keep dividing it by 1.02 to the appropriate power. And note that the growth rate has already been accounted for in column G. Column H is only deflating it by the rate of inflation. Okay, the next method is CF real cash flow using method 2. So it is CF real T minus 1 times 1 plus RGR. And as we defined it, RGR is nothing but 1.1502, which is the 1 plus G divided by 1.02, 1 plus pi minus 1. So that is RGR. Now, so CF1 is going to be this divided by 1.02. That is the real cash flow for the period 1. But the next cash flow is this times parenthesis 1 plus $I $1. So its growth rate is itself inflation adjusted. So you can see same answers. So Control C, Control down, Shift Control up, Control V. We got the same answers. Going to CFR3. Again, the initial cash flow, because it's at T equals 0, does not need to be inflation adjusted. The first cash flow is also calculated using the same way, divided by 1.02. But the second cash flow onwards, so CFT is CF1 divided by 1 plus pi, which is pi, which is what we just calculated. So CFT is this guy, and then times 1 plus G divided by 1 plus pi to the power T minus 1. So basically 1 plus RGR. So let's just Control R to the RGR. So equals $J $4 times parenthesis 1 plus $J $1 to the power of F5 minus 1. Same answer. Control C, left, Control down, Shift Control up, Control V. Notice all the cash flows look exactly the same. So we found out real cash flows using 3 different methods, and we have nominal cash flows. So the principle is discount the nominal cash flows using the nominal rate. So equals NPV, the nominal rate, comma, nominal cash flows plus the initial cash flow, which is G3. Enter. That is our net present value. Real cash flows will be discounted using the real rate. So remember, 15.02 is the growth rate, but MARR is 15%. So to find out the real MARR or inflation adjusted MARR, we do 1 plus the nominal MARR divided by parenthesis 1.02, which is the 1 plus inflation minus 1. That is the inflation adjusted MARR. So equals NPV. For the sake of simplicity, I'm just going to use a dollar sign. $K $24. That is the rate. And then the real cash flows, since all of these are real cash flows. So plus the initial cash flow. Same answer. And then Control R, you can see using different different column cash flows, but using the same hurdle rate, which is the inflation adjusted hurdle rate, we got the same value of net present value, which is the same as what's obtained in the example. And that is example 9.2. Thank you for listening.